Good evening, ladies and gentlemen. This is your well-rounded math teacher, Mr. Picard. And we're going to go over 8-6 compounded growth with logs. We're going to use logs to solve some of these questions working with interest. There's a couple formulas that I'm going to show you to find out how much a loan is worth after so many years, or how much like you would have in a savings account if you put money into a savings account after so long. And the first formula I want to show you guys, well, hold on here. Is this. Okay, let's go A. We worked with this last time. This was a growth formula. This is also a growth formula working with interest and being compounded so many times per year. So there's another variable I want to show you. A, that's the initial amount. Actually, it's the final amount. P is your principal, your interest amount, or initial amount, sorry. Boy, I'm a little off today. Okay, here we go. And then it's 1 plus again, your percentage rate, but now this is divided by K. Now, K is that variable that we use. It's how many times your interest is compounded. Like sometimes it's kind of like simple interest, it's only compounded once a year. But if it's compounded more than once a year, which would increase the money in the account, if it's compounded more than once a year, this is a formula we would use. And then K to the KT power. So real quick, this is my final amount after a certain time period. This is your principal, this is your initial amount. Okay, I forgot an I there. It's also called the principal. Okay, just so you got to kind of know that. T is time again, and it's always in years for this formula, always in years. Now K, which is in 2 spots, K is the number of times your interest is compounded. Okay, so like if they say it's compounded monthly, then K would equal 12. Because there's 12 months in a year. If it said compounded daily, like this, well, how many days in a year? Well, there's 365, so then K would equal 365, just so you kind of know what's going on with this formula. It's a little bit more complex because you added the K in there, but that's the only thing. So let's go to this first problem. It says Claire takes out a loan for school for $9,000 at an interest rate of 6.3%. The interest rate is compounded right here, compounded annually. Well, annually means once a year, so K is equal to 1, so it really doesn't change it that much. How much would the loan be worth after 5 years? So we want to find the amount. If 9,000 is initially put in for your principal, it's going to be 1 plus. Okay, remember your percentage rate. It's got to be a decimal, so you're always taking your percent and dividing by 100, or move your decimal over twice. Well, 6.3 divided by 100 is 0.063. All over K, well, if K is compounded annually, that means K is equal to 1, because it's once a year. Just so you kind of get used to this formula, real simple. And then K times T, well, 1 times 5. And you're always going to multiply these first. before you plug it into your calculator. So this is what I would do. I'd take the 9,000, 1 plus, and I know I could divide 0.063 by 1, but I just want to show you how you would plug it into your calculator, and you should get it right every time. You got to divide before you add in the parentheses here. So if you plug it in just like this, you don't need to use any other parentheses inside the parentheses. And then 1 times 5 is 5. So plugging this bad boy in, we would just do this. 9,000 parentheses, then put all that work in there. 1 plus 0.063 divided by, well, 1. It's not always going to be 1, though. That's why I'm kind of showing you this. Finish parentheses off, hit the A to the B button, and then type in 5. And there's our answer. Let me get a little room here. Our A, in this case, is equal to 12,215, and what do you got there? Round it to the nearest cent, so it's 0.432, so that'd be 0.43, so 43 cents. Okay, that's if your interest is compounded once a year. Now let's look at this one. Basically the same problem, but now they want us to compound it daily. Okay, daily, right there. That means K is equal to, well, how many days in a year? 365. So when we're doing this formula, everything else is the same except K is now 365. So it's going to be 9,000 times 1 plus your percentage rate as a decimal divided by 365. Now, it's always to the KT power, so it's 365 times 5. So the K times the T. You can use parentheses with this, but I usually just find that number real quick and type that in when I type in the formula. But I always multiply that and just get one number. So 365 times 5, well, that's 1,800. 1,825. So now when I plug it in, 9,000 parentheses, just type it in that formula we just put the numbers into, 1 plus 0.063 divided by 365. Now I gotta finish this off by finishing off the parentheses, hit the A to the B button, and then we're gonna type in our new number here, 1,825. Let me get it right. And there we go. Something ain't right. Let me try this again. 365 times 5. Let's do 9,000 parentheses 1 plus 0.063 divided by 365. Finish off the parentheses. Caret key, 825. There it is. I must have typed it in wrong the first time. So that gives me A equals 1,200 or 12,331. And 99 cents, point 998. Well, that's going to round up to a whole dollar. So actually, we're going to get a 2 here, 0.00. So this is more, same time, but this is more than the 215. It's 332. And the reason is the interest is compounded daily. It's compounded 365 more times. So you're going to make more money every time the interest is compounded. So just keep that in mind. Now the next one, it's going to be compounded hourly. So a couple things going on here. What is K going to be then? Well, it's compounded hourly. That's 24 times in a day, and there's 365 days in a year. So K is going to be 365 times 24, whatever that is. Let me pull it up here and multiply that. Okay, give us a little room. 365 times 24. So 8,760. That's what K is. So plugging this in, it's the same thing, except K is different. Now it's compounded more, so I should make a little bit more money in the interest. Okay, so it's 9,000, because that's my P, initial amount, 1 plus the percentage rate, 0.063, all over 8,760. To the, okay, so this is K, 8,760 times 5. Well, I want to know what that is first, so I'm going to multiply those out quick. 8,760 times 5. So the number I'm really going to plug in here for my exponent is 43,800. It's going to be more interest. I don't know how much more it's going to be when you compound it 24 times a day and then 365 times a year. But let's see. Let's just plug it in. So 9,000, hit the parentheses, 1 plus 0.063 divided by K, and K is 8,760, and then raise it to that power of the K times T. Finish the parentheses off first, and that's going to be 43,000. You would think it would be a ton more, but it's really not that bad. There it is. So this A is going to equal 12,332 again, with 32 cents if you round it. So it goes up a little bit more, but you get 32 more cents by compounding it daily instead of, or hourly instead of daily. So that's where we're at. So now we get to this. Compounded continuously. It's just done over and over again. And you make the most money off from compounding continuously if you like put money in a savings account, or you actually have to pay a ton more interest. I wouldn't say a ton more. You're going to see in a second here. Compounded continuously. There's a different formula for this. They call it the APERT formula because if you read it, it looks like APERT. But A is the same. That's your final amount. P is the same. That's your initial amount or your principal. Then it's times E to the RT power. This RT up there, that's an exponent for E. And remember, E is that continuing number. It's kind of like pi, 2.7182. And then it kind of continues on. And I'll show you how to use that on Desmos. And there's an E to the X button on your graphing calculators and your TI-30s that you would use the same way. But we got to remember, it's not E times RT, it's E to the RT power. This is an exponent. And that's where some people make mistakes. Okay? So anyway, same problem. What is A? Our principal is 9,000. Now we're working with E. Our rate is 0.065, or what was it? 0.063, right? That's a terrible 3, so let's try it again. 0.063 times 5. So the way I would do this, you could put this all in parentheses here and multiply it, but I'm just going to find out what that number is. So I'm just going to use Desmos again here. You could use a graphing calculator, same thing. It's less chance of making a mistake. So 0.063 times 5. So 0.315. Let's get my pen back here. 0.315. And just plug that into your calculator, okay? So P is 9,000. Whoops. 9,000. I'm going to hit times here. I don't think you have to, but I will. Hit the ABC button and just hit E. There, and it's multiplying 9,000 times E right now. Go back and then hit the A to the B button. And that's the 0.315. There it is. So the interest and the money you have after 5 years that compounded continuously, A equals, put the money sign now, 12,000 again, 332, and then 0.33. So it went from 31 cents to 33 cents. Compounded hourly to compounded continuously. So it's not a huge jump there, really. But if you had more money involved and you were paying off like a house loan for like $250,000, there could be quite a big difference between these two, depending on how much money you're taking a loan out for over a time period of 30 years. So kind of keep that in mind too. So moving along here, we're going to apply some of these things that we've learned. So there's basically two big formulas. This one is only when it's compounded continuously. If it's compounded hourly, daily, monthly, whatever, then you're going to use that formula we started out with up here. It's a little bit more complex because you're working with that K compounded so many times a year. But now, if you deposit $100 into an account paying 3.5% interest compounded continuously, so that means we're going to use the A-PERC formula. A equals P times E to the RT power. That's an exponent there. How long will it take for your account to reach $1,000? So that's a final amount. That 1,000 is equal to A. So we have to use logarithms to solve this, and I'll explain why in a minute. We want to find time. How long will it take? So T is going to be our exponent. So it's the variables in an exponent, so we're going to have to use logarithms to solve this. So plugging things in, A is 1,000 equals 100. E to the RT power. Well, your percentage rate is 3.5, so you got to take 3.5 and divide that by 100, and that's going to give me 0.035. So this is 0.035 T. E is not a variable. E is a number, okay? And we got to remember here to solve this, E is my base right now. And my variable is in the exponent. So how do we write this? Well, first we got to get rid of the 100 because that's not part of the base. So get that by itself. That base by itself is basically what you want to do. 1,000 divided by 100 is 10 equals E to the 0.035 T power. So if our base is E, you would say, hey, This is log base e of 10 equals 0.035 t. But we don't use log base e. Log base e is that ln. So it's basically, this is what you got to get used to when you're working with e, the ln of 10, and that's got to be in parentheses, equals 0.035 t. So how do I solve this for t? Well, once you get that logarithm in there, that ln, just divide both sides by 0.35. That'll cancel that out, and then you got t by itself, which is what you want. So this is what I'm going to plug into my calculator. Okay. Let's go back here a little bit. So ln, go to functions, and ln is in that first column. It's 1, 2, 3, 4 down right there. 10. Finish off those parentheses first, you have to, and then divide by 0.035. And there it is, 65.8 roughly. Now what does that mean? 65.8 time is going to equal 65.8 years. Or if you round it, it would you couldn't do it in 65 years, it'd take at least 66 years. But I'd take 65.8 also. So 66 years before that $100 will turn into $1,000 if it's at 3.5%. So it takes a long time to get your money 10 times the value, 66 years, so you want a higher percentage rate for things like that. Okay, what we got here? Let's finish this up. Okay. Suppose you deposit $2,000 in an account paying 2.8% annual interest, compounded continuously. Well, as soon as I see that, continuously, I'm going to use the APERT formula. Again, whoops, I wrote that wrong because RT is an exponent. Remember that? What is the balance after 10 years? Well, this is a pretty straightforward problem. You want to find A. They don't want to find T, so we're not going to have to use a logarithm to solve this. I'm just going to take that 2,000, my principal or initial amount, E, okay, 2.8 divided by 100 is 0.028. So RT, 0.028 times 10. So the way I'd do this, I'd take 2,000 times E. I'd multiply these two first. 0.028 times 10 is 0.28. So I just multiply that exponent, those numbers together, so I can just simply plug this into my calculator now. Boom. Let's go over here. And it's going to be 2,000. To get that E, just hit the A, B, C button, hit E. Go back and exponent. What is it? 0.28. There we go. So the 2,000 will go up to $2,646.26. So A would equal, what is it, $2,646.26 if you round it. And that's it. That's how you do it. Pretty simple. Now, this next one, give yourself a little room. It says, how long will it take the balance to reach 5,000? Well, that's your final amount right there. So you want to go from 2,000 to 5,000. So plugging this into that APERT formula, you want to solve for T now. So you're going to have to use logarithms here. Well, 2,000 to 5,000. So 5,000 is A, your final amount. That's what you want to get to. 2,000 E to the RT. Well, my rate was 0.028 as a decimal times T. So once again, got to do a little work here. Here's my base. Here's my exponent, right? But first, I got to get rid of that 2,000. I can't multiply 2,000 in E because 2,000 is not a base. So divide by 2,000. If you plug that into your calculator, you're going to get 2.5 equals E to the 0.028 t. So E is my base, and like I said, my variable is the exponent. So I'm going to take log base E, which is just ln, that's log base E, of 2.5 equals equals your exponent, 0.028 t. And to solve this, to finally solve it, divide both sides by that 0.028. So t equals, well, let's get over here and plug it in. I need that ln button, 2.5, finish off parentheses, and then divided by, what do we got? 0.028. Oh, geez. There we go. So it's going to take this 32.7 years to get to $5,000, or basically 33 years. So those are the type of problems you're working with on the assignment. If you have questions with it, send me a message and I'll work on it. Other than that, we'll see you guys later. Take it easy.